Alright, I wanted to go over oxidation numbers real quick because there still seems to be a little bit of confusion as how to use them to your advantage. First of all, we know that oxidation numbers basically show how many electrons will get transferred or shared during a chemical reaction. Now, if we look at group or family number 1, we know they have one valence electron. They're eager to transfer that off to somebody else. So if they lose an electron, that means they'll have more protons than they have electrons. In this instance, they are going to transfer 1, meaning that their protons are going to be outnumbering their electrons by 1 subatomic particle, which is positive. So that's where the 1 plus comes. Okay, it's the oxidation number then becomes 1 plus. For example, if I'm lithium, I have 3 protons, 3 electrons if I am a neutral atom, but as I become an ion, a charged atom engaged in bonding, I'm going to give up that valence electron, that 1 valence electron, and that'll leave me with 3 protons and only 2 electrons. Hence 3 positive, only 2 negative, your 1 positive is your charge. So that continues on, and if you still don't understand this, I want you to seek me because we've talked extensively about this, but come see me. But if you make sure your periodic table is labeled as 1 plus, 2 plus, and then we have 3 plus, and then all the way to the carbon group that can either take on electrons or give up electrons, and then here we have we're going to gain 1, gain 2, gain 3. Of course, these are our noble gases, and they are not engaged in the bonding process. Okay, so now let's look at how we're going to use this information and let it work for us. Well, yesterday you guys came across an activity, and we were working on this as a class and then independently, and you came across an example that you were supposed to make of an ionic bond between magnesium and iodine. Well, we found out that iodine is a 1 minus, and magnesium is a 2 plus. Okay, so if we're going to have to combine these, we see that there are 2 here, only 1 here. Some of you said that won't work. Well, how could we make that work? Well, if we had 2 of these, y'all said. Well, that's exactly what we're going to do. We're going to add another one because now we have enough to satisfy this, right? That'll work. So they can bond if they are 2 iodine. So use these oxidation numbers to your advantage. Another example, I'm not sure if we have any more. Carbon and oxygen, for example. Carbon, we know, can be either 4 plus or 4 minus. And this is now a covalent bond between 2 nonmetals. Oxygen, on the other hand, has a 2 minus. So we're going to go with the 4 plus, but we need how many more oxygens? Well, we're going to need another one to satisfy this relationship or this bond. Okay, we're going to practice that more today when I see you, but I just wanted to make sure that you are understanding oxidation numbers and letting them work for you.